Let's talk about some advanced class concepts in C++. So first we'll talk about const parameter modifier, right? So we know that we can pass class objects into functions by value, right? And if we do that, it creates a copy of that object, and this could be inefficient, right? Now we can make it more efficient by passing it by reference, right? This is going to be fast, but it also allows the object to be accidentally modified within the function body. So we can combine these concerns by passing in parameters by const reference, right? And this gives you speed, uh, but it will also throw a compilation error if that uh, parameter is modified inside the function body, right? Also, if you have a function that only reads data and does not modify any of the object state, you can put a const at the end of its prototype or at the end of its definition, and the compiler will make sure that it does not modify the object's state. So let's take a look at some code that illustrates this. So here you have a class definition for item, and it contains a couple of function member functions that are marked const. Now the trailing const makes sure that these functions don't alter any internal state of that object. And then here's an example of a global variable, of a global function. This is not a function that is part of a class, right? It is a standalone function. And we have a couple of parameters that are passed as const reference. And what that means is that the compiler will make sure that this function body doesn't allow those to be changed. Now let's talk about inline function. Now, what are inline functions? Inline functions are functions that are defined entirely within a class declaration. So let's take a look at this example. Here you have a class declaration, and the function get price is defined here entirely. Note that this is no longer just a prototype. It is a full definition because I have the body defined here, right? Now, these have the advantage of faster execution because the compiler does some text replacement optimization rather than calling a function, which can be expensive. Uh, but it has the disadvantage of blurring the line of keeping the interface and implementation separate, right? So you would want to use them strictly for short basic routines such as getters and setters, right? And not anything beyond that. Lastly, I want to talk about a static modifier. Now, so what is this? A static member variable or a static member function uh, is said to belong to the class itself and not to an instantiated object, right? All the instantiated objects share exactly one copy of a static variable, right? So this, it can be thought of as belonging to the class and not to individual objects that are instantiated using that class, right? Static variables must be explicitly defined and initialized outside the class definition scope, right? We will take a look at what that means in the code in a little bit. Static functions can be called without needing to have an object created first. We'll take a look at an example of that too. Uh, but when you define these functions, they can't refer to any non-static member data fields. So there's a lot there. So let's take a look at an example here. So what do you have here? You have a class uh, declaration for item, right? And inside it, it has a static member variable, right? And it has also a static function, right? And we've said that a static function can only use static variables, which indeed it is using, right? Okay. and then you have the constructor here, which increments the static variable, right? And that's perfectly fine. Uh, Now, we also said that static variables need to be initialized outside the class scope, which we're doing here, right? We are setting it to 0. Now, what's actually happening here is that any time that something of type item is created or declared, the constructor is called and the static variable is incremented. Since all objects share a single copy of the static variable, right, this keeps on getting incremented every time an object is declared. And that's exactly what happens here in main. We declare three different variables of type item. So for each of these, the constructor would be called and total items would be incremented. So in the end, when we print them using get total items, it should output 3. So we can try this out. We can go to our IDE, and I've already pasted it here. And if this were working properly, it would indeed show 3. Now, if you go ahead and include another one, let's say D, it should increase to 4, which it does, right? Or if you get rid of two of them, right, and run this, it should be 2, right? So it's actually is an object counter that we have implemented here.